to explain the second portion of my organic revision marathon, A2 organic chemistry past paper questions. Let's get started. How to solve past paper questions? Basically, there are few main selected questions. Difficult questions, tough question, unexpected question, sometimes most frequently asked question, etc., etc. Let's see over here. For example, this is the question that is having a sequence or that is composed up of different steps. 6 steps are there over here. And we are starting from the benzene ring. This is the benzene ring. Step 1, step 2, step 3, step 4, step 5, step 6. In step 6, we are using phenol as a reagent. And finally, we are supposed to make this azodide. So what is the difference between very much initial compound benzene and this one, the last one, benzene ring? The last one, azodide, So here is the benzene as a starting material, and in this portion, we are having having 2 benzene ring in it and a huge compound. But you have seen that in final stage, as we have used phenol over here. Here is the phenol, this one, this portion. So rest of the portion is going to be originated, or it's going to be formed, is going to be synthesized from this benzene ring. So this is the basic benzene ring, this one. It's having a carboxylic acid group. It's having an double bond group, and it has been synthesized from the previous one, step 1, step 2, step 3, step 4, and step 5. So now you will have to think about it. First of all, just think yourself, make a scheme in your mind that which one step should be the first one, then second step, then third step, and fourth step. हमें सबसे पहले बेंजीन रिंग के ऊपर किसको लगाना है? ये N ट्रिपल बॉन्ड कैसे आएगा, N डबल बॉन्ड कैसे आएगा, एंड सो ऑन. हमारे पास N ट्रिपल बॉन्ड कैसे आएगा, N डबल बॉन्ड कैसे आएगा, हमारे पास कार्बोक्सिलिक एसिड कैसे आएगा, हमारे पास this junction that is going to be formed over here between phenol and N double bond, ये कैसे आएगा, कैसे होगा? That is the basic and major theme of this question, or technique of this question. And you know that there are the different groups, those are having different orientation. Some group, if they are present on the benzene ring, they send other group on para position, at 4 position or 2 positions. And some group are said to be meta director. Those are going to direct the other group. For example, carboxylic acid. If the carboxylic acid is present on the benzene ring, then it is going to direct the new incoming electrophile on these positions. These are called meta positions, or 3 and 5 position. So the major main phenomena in this conversion, in this complex conversion, is which one should be substituted on the benzene ring first. First of all, let's suppose I'm going to substitute a methyl group on the benzene ring. So in step number 1, if I'm going to react it with CH3Cl, I'm going to add AlCl3, plus I'm going to heat under reflux. So there is a substitution of 1 hydrogen of benzene by CH3 group. Now, the second step, what will be the second step? This CH3 group is basically OP director. OP director. This compound is going to direct the molecule towards ortho, or para position. If I'm going to introduce this molecule, this benzene ring, to nitro group, I'm going to add HNO3 plus concentrated sulfuric acid, both are concentrated, and I'm also going to heat it up to more than 60 degrees Celsius. then what will happen? There will be the nitration on this position. Here is methyl group that is already present on the benzene ring, and here there will be the introduction of nitro group on this benzene ring. So this is the basic first, expected sequence. I started from the alkylation. First of all, I introduce methyl group on the benzene ring. Then I make nitration of the benzene ring. Now, in next step, what to do? Should I change this methyl group into carboxylic acid? Or should I change this NO2 group into the NH2 group? First of all, I'm going to do side chain oxidation. So I'm going to change it into carboxylic acid. This is a side chain reaction. Here I'm going to introduce KMnO4. I'm going to add acid. I'm going to heat it, and this is the oxidation of side chain. And same as you know, here is the presence of NO2 group. Now, what is the next step? Next step is to change this NO2 group into NH2 group, and this is called reduction, partial reduction of nitro group that is present on the benzene ring. So here is C double bond O, OH, and here it will be NH2. Now, how? By putting 10 plus concentrated HCl, and in next step I'm going to add OH negative ion to neutralize the excess acid, plus heat as well. So this is called nitration, reduction of nitro group. NO2 will change into NH2 group. Now finally, what is on this stage here, there will be change of this NH2 group into N triple bond positive charge. This is called a diazoniamine. So what will be the reagent and condition? I'm going to add NaNO2 plus HCl, NO2 plus HCl plus 0 to 9 degrees Celsius temperature. So this NH2 group will change itself into this one ion, diazoniamine. Now this diazoniamine is supposed to react with this phenol, and in step 6, basically in the presence of sodium hydroxide, that is the final reaction that is going to make an azodie. And here at the para position, one double bond will be shifted over here at the para position of this OH group, and finally we are having this azodie. So this is the basically a sequence of different steps to make this azodie from simple aromatic compound that is called benzene ring. Next question is this one. Again, once again, we will have to see the directive influence of the different group. We are starting from the benzene ring. We are finishing with this compound that is basically 4-isopropyl phenylamine. Its name is 4. This is position number 1, 2, 3, and 4. 4-isopropyl or secondary propyl, and phenylamine is the name. So how to convert this benzene into this one? The first step, the basic step, the normal step is check the difference between the first and the last thing. Once again, there is a normal benzene ring, and finally we are having NH2 group on the benzene ring, and we are having an other alkyl group on the benzene ring. So now once again, we will have to see which one group should be introduced first. Benzene directly cannot be changed into NH2 group. You cannot introduce directly NH2 group on benzene ring. First step is to introduce nitro group. We will have to make nitration first, or in this case, we will have to make alkylation first. So what should be done first? Just have a look. So if I'm, for example, the one strategy, what is the X? I'm going to change this benzene ring into alkyl benzene, and here it is. So first of all, I'm going to change it into alkyl benzene, and here what are the reagent? CH3CH. जिस पॉइंट को आपने बेंजीन रिंग के ऊपर अटैच करना है, लगाना है, जिस कार्बन को उसके ऊपर Cl लगाओ, CH3 in addition to AlCl3 anhydrous mean without water plus heat. So first of all, I have introduced this isopropyl or secondary propyl group basically. Next one, after this one, I'm going to do nitration. HNO3 fuming plus fuming H2SO4, I mean fuming mean concentrated, and 60 degrees Celsius at least. So what will be done? Basically, this is an alkyl group and it is, ortho-para director group. It will direct, or it will basically give the chance to the incoming electrophile to sit over there. I mean, there are the 3 active positions because of this group. But this is a bulky group, so these positions are least likely to be occupied. So its phase position, that is 4th position. Here I'm going to introduce nitro group. So the more chances of the nitro group should be there. It is called major product. It is called major product. Yes, there will be the minor products as well. Those are having NO2 group over here, but I'm going to have this one. In this case, as you have seen that this is not very much activating group. It's the least activating group. So we will have to use sulfuric acid as a catalyst. If you're having any active group or like OH group, like NH2 group, then there is no need to put the catalyst. There is no need to use the heat as well. You will put just nitric acid. अगर आपके पास कोई एक्टिवेटर लगा हुआ है बेंजीन रिंग के ऊपर, तो आप उसमें सिर्फ नाइट्रिक एसिड ऐड करेंगे और आपका रिएक्शन हो जाएगा. और अगर आप डाइल्यूट नाइट्रिक एसिड ऐड करेंगे, 1 nitro group लगेगा. And if you are going to add concentrated nitric acid, then there will be multi-nitration. I mean, nitration may be in at three places, over here, there, and there. That is said to be multi-nitration. But in this case, it's the least activating group. So most probably we will have to use sulfuric acid, or we will have to heat as well. So the last step is to change this nitro group into NH2 group. So again, tin metal plus concentrated acid, HCl especially, not any other acid, and then heat as well, plus at the end we are going to add OH negative ion to neutralize the excess acid. So in this way we can convert this benzene into this one secondary propyl phenyl amine. So as far as my opinion is concerned, this is exact or correct mechanism or the correct pathway to make first Y and X and Y. If I'm going to make nitration first, for example, I'm going to introduce NO2 group, then this NO2 group is not OP director. Then we will have to change immediately into this one that is having over there an H2 group over there, and then you can introduce an alkyl group over here. So in my opinion, this is the exact, whenever you are going to introduce 2 or more than 2 different group on the benzene ring, listen it carefully. Whenever you are going to introduce more than 1 substituents on the benzene ring, so as far as my priority sequence is concerned, you should introduce alkyl first. At first step, you should introduce alkyl, then you can introduce any other one. For example, as you have seen, I introduced nitro group on this. So this is my own experience, you can say, my opinion, and as far as my experience, opinion, or you can say his rule is concerned, that is an easy way. Now come to the next one. There is another, this almost same question. One of, you can say, the tough question or toughest question. Here is synthesis P is here the starting material P, and we are changing itself into this compound. Basically, here Q is unknown, R is unknown, and S is unknown. In these type of a question, as I mentioned over here, you will have to apply a reverse strategy. A retro strategy should be used over there. वो क्या है कि सबसे पहले, I'm going to start from the bottom. I'm going in a backward direction, in a backward way. So in this case, you have seen that where is the original P? This one P is lying over here. Is lying over here, right? So this is the original P, and almost P, because this nitro group has been changed. And this is the new compound that is having 2 methyl group over nitrogen over here, and this is the one benzene ring. So once again, I'm going to start from this one to make step 1 and step 2, then I'm going to mix it with S. Basic thing is this portion is coming from P. This portion, this encircled portion is coming from the P. So what are the changes expectedly over here, or what should be done with the nitro group? It should be changed into, first of all, NH2 group, then NH2 group will change into diazoniamide. And obviously, this is the R that is coming from the second side. The second molecule is this one, S1. So in my opinion, I'm going to mark it over here. This is, you can say, an S that is having CH3 over here. Now, what is the Q basically? What is expected answer of this Q? It will be C double bond O, OH, and here is NH2. That is reduction. In next step, that is azotization, you can say. It is like that. C double bond OH. It is going to change this nitrogen double bond, and here must be at least positive charge. So this is the sequence, and I sorted out in a reverse strategy to moving in a reverse direction. So these are the 3 possible answers. Now he is asking to find in next step what is the name of P, and you know what is the P? This is the P. It is having this major functional group, this is minor functional group, and this carbon will be carbon number 1, and obviously the closest position is this one, 2. If I'm going to move like that, if I'm moving anti-clockwise, then its position will be 6. That is not valid position. So at 2 position there is nitro group, and this is the major functional group. Its name will be written with the benzene ring. How? As I told you in my previous lecture. So 2-nitro. 2-nitro benz. Benz mean benzene ring, and for acid, OIC acid. So the name is 2-nitro benzoic acid. Once again, 2-nitro benzoic acid. Yes. Next thing, P can be synthesized, shown over here. This CH3 is going to change itself into COOH. Region and condition for this reaction, very much famous question once again. This is side chain oxidation. You will add directly acid plus KMNO4. Sometimes you can add alkali as well, but at the end you will have to add acid. Don't forget it. So I'm going to heat it as well. So these are the basic reagent and condition to oxidize this compound. A student attempt to synthesize P by an alternative route in this figure that is shown over here. And this is already, it's a benzoic acid. He is using concentrated nitric acid and sulfuric acid, and there is the 1-nitro group over here, and so on. Now come towards another question that is over here. Once again, we are starting from the benzene, there are the different steps, and finally we are making this Q, this one, And how to synthesize it? Again, as far as my opinion is concerned, see this question in a reverse direction till benzene, and then you can reconfirm it starting from the benzene ring. This is very much simple B. Why it's simple? It's easy. Step number one is easy. Why it is easy? Because here there is a molecular formula. What is the formula of this benzene ring? It is C6H6. But what is the formula of this B? C6H5Cl. One less hydrogen and one more chlorine. Mean there is substitution of chlorine on benzene ring. So it's a chlorobenzene. Now come towards step 3. Can we do it directly? Yes, we can, because now we know that to introduce NH2 group on benzene ring, first of all, we will have to introduce nitro group on the benzene ring at the same position. So in step 1, basically you know HNO3 concentrated H2SO4 plus 60 degrees Celsius, and we are going to have nitrobenzene. In next step, step number 4, we are going to have 10 plus HCl plus OH at the end and plus heat. So in this way, we can synthesize this phenylamine or aminobenzene. What is step 2? Step 2, we are supposed to react this molecule with the benzene ring, but first of all, we are going to mix it with AlCl3. What is the function of AlCl3? The function of AlCl3 is, I'm going to write this molecule once again over here. This is C double bond O and Cl, again C double bond O, Cl, if I'm not wrong. This is this one. If I'm going to add AlCl3 into this molecule, so there is a chance of removal of one or both chlorine. One or both chlorine. Just keep in your mind. There may be the chances of detection of removal of both chlorine atom. Yes, it is true. It's possible. There is the chance of removal of at least one Cl from over here. Now, what is the final compound that is supposed to be formed over here? That is C. So I'm going to check it. C4, C8, H4, O2, and Cl2. Initially, as you have seen that, we are starting from the B. It's having C5, C6, H5, and Cl1. So what is the difference between B and C? There are two more carbons, C6 to C8, one less hydrogen. One hydrogen is less over here, right? I mean, if the benzene is going to change into any compound and the formula is having one less hydrogen, then simply it means it is going to give electrophilic substitution. I mean, it's replacing its H and it is going to have another group. And the next thing is O2. Initially, there were no any oxygens, but here is oxygen now in 2. And there is one more Cl. Here was initially one Cl, and there is one more Cl. So it means that it looks like that two more carbon, two more oxygen, and one more Cl. 2 carbon, 2 oxygen, 1 Cl. 2 carbon, 2 oxygen, 1 Cl. So from here, this AlCl3 is removing this Cl only, and this carbon is going to have positive charge. I mean, what is this AlCl3 is doing over here? Let's see over here. Cl, C double bond O, positive charge, plus AlCl4 negative is supposed to be formed. So it will react with B, this benzene ring, and I mean it will make this C compound. So what is the possible structure? I'm trying to write it over here. I'm going to write Cl over here, and at its para position, Cl is also, chloro group is also para director. I mean, it is also ortho para director. As it's a bulky group, so it will be attached at its position number 4, or that is called para position. So this is the structure of C, if I am not wrong. Now, is supposed to react with this one molecule, that is phenylamine. And you know that this amine is basically is acting as a nucleophile. NH2 group, NH2 has different functions. It may have acting as a nucleophile. It may act as a ligand. You have seen in chapter number 5 in inorganic chemistry, and it may act as generally a base. So in this case, what is happening? In my opinion, I think it will attack on this carbon atom. This is a partial positive carbon and this is a partial negative oxygen. So it will attack on this carbon, and this is called basically addition elimination mechanism. Basically, AlCl3 are all acyl chloride, not AlCl3, acyl chloride, I'm sorry. All acyl chlorides gives addition elimination mechanism. So first of all, I'm going to make it over here, and this one, I'm going to trying to write the previous one. This is the older one, you can say, C double bond O. Right, 1 minute. C double bond O, again C double bond O, and I mean here was Cl initially. Now there is only one Cl left behind. There were two Cl, you can see that. So one Cl has gone, and here is basically N, this one NH with one less hydrogen. ये NH2 जब अटैक करेगा तो H from here and Cl from here, HCl is formed. The remaining portion of this molecule is this one. So this is E, C14, H10, and one nitrogen, two oxygen, and one Cl. So this is called E, this compound. Finally, it's going to change into step 6 into Q. What is the difference between Q and E? The basic difference is that there is no any sort of C double bond O. All C double bond O have been removed. Yes, wow. This is a keto group. Basically, it's a ketone. This C double bond O is going to constitute ketone functional group, and this carbon is going to constitute imide. So we are supposed to reduce it. Whenever we are going to add especially lithium aluminum hydride and in the presence of ether, so there is a reduction of ketone, and ketone, whenever you are supposed to reduce ketone, it will change into secondary alcohol. This portion comes from keto group, from this group, this one. And what about imide linkage? Whenever you are going to reduce any imide, it will change itself into primary amine. It will change into primary amine. So this one carbon was present over here. C double bond O of imide has been changed into simple CH2 group, and finally we have made this Q. So these are the tricky questions, tough question. You should practice these questions by yourself at least once or twice. There is another question comparing the molecular formula, especially, I mean, you are starting from the benzene ring and methyl. This is methyl benzene. You are supposed to make K and J. Once again, compare the molecular formulas for the, to solve this question very much easily, for your own easiness. C7, HCl, Cl, H7Cl. What is the formula? C7, 6 carbon over here, 1 over here. So C7, how many hydrogen are there on benzene ring? 5 plus 3, 8 hydrogens are there. So initially it was C7H8. Now it has become C7H7, 1 less hydrogen, 1 more Cl. Mean there is substitution of 1 Cl group. So both are having the same molecular formula. Same. Both are having same. This is also having C7H7Cl, C7H7Cl. Now, there are two different conditions to make these two different compounds. Obviously, compound J and K are not same. If I'm using AlCl3 plus Cl2 plus heat under reflux, then simply speaking, I am going to introduce Cl on the benzene ring. Then I am going to introduce Cl on the benzene ring. So this is a substituted product of benzene ring. In this way, the formula is this one. If I'm going to change the condition, if I'm going to use UV light, and if I'm going to add Cl2, nothing else, I'm not going to use any AlCl3, then side chain is supposed to react with this Cl2. And again, there might be the possibility of the same formula. So there may be the chance of formation of this molecule, that is CH2Cl. I mean, this is chlorobenzyl, it's generally a haloalkane. It's not a chloro, or it's not a chlorobenzene, or it's not an aromatic halide, you can say. So this Cl is going to attach with the side chain. There is the possibility of formation of second Cl over here, dichloro or trichloro. But one of the major possibility, or one of the common possibility, is you can synthesize both compound from this compound by using different reagent and conditions, but they are pretty similar. So here asking to find the reagent and conditions, I mentioned them over here. So just keep in your mind that whenever you are going to treat benzene ring, so you have 5 major reaction of benzene ring, and then you will see its substituent. This is substituent. It may be an alkyl group, it may be an nitro group, it may be an NH2 group, it may be a keto group, it may be an acidic group. So there are basically overall, in general, in organic compounds, especially in A2 organic compound, there are 2 portions of the organic compound. One is benzene ring itself. It can change itself into 5 different ways, into 5 different compounds, as I have told you in my previous lecture. And then the next chemical property, next chemical reaction may be due to the branch, may be due to this substituent, and so on. Same is the case once again, is having carboxylic acid, and now C7H5ClO. C7H5ClO2. The difference in both compound is just of 1 oxygen. So how to make these 2 compound? How to make M? How to make this L? How to remove 1 oxygen and introduce 1 chlorine? Rest of the portion is same. If I'm going to write this formula once again, C7H6O2. So this is the original formula of this molecule. Now again, there is a removal of 1 hydrogen, introduction of 1 Cl, and rest of the oxygen. 1 oxygen is also removed. So in this case, it means that benzene is not going to change itself. Benzene is not going to take part in chemical reaction, because 1 less oxygen mean oxygen is not the part of the benzene ring. So it means that this side chain is going to participate. So what we are doing, or what we can do, we can introduce PCl3 or PCl5 or SOCl2 or red phosphorus plus Cl2 plus heat, etc., etc. So there will be the substitution of OH group by Cl. This is the compound M formed, and here it is formula. Now come toward this one. In this case, both oxygen are intact with the molecule. So COOH group is not going to do any chemical reaction. This time, benzene is going to show the chemical reaction. So I think once again Cl2 and AlCl3 plus heat, and you will get this 1 compound. But remember that this carboxylic acid, this acidic group, is meta director. It's 3,5 director. It's going to send the incoming electrophile on meta position. So you are not allowed to write over here, or over here. You can write over here, you can write Cl over here, and so on. So this is the one of the possible option and answer in both cases with the reagent. The next question that may be asked usually, that is from the past, AS chemistry section. So what is the question? The question is, basic question is, how to find the chiral carbon, number of chiral carbon atom in this molecule. So simply speaking, basically CH3 group are not chirals, carbon of CH2 group is not chiral, carbon of double bond, any double bond is not chiral, carbon double bond oxygen is also not chiral. So let's see over here. It's a CH2, it's not chiral. Double bond carbon is not chiral. CH2 not chiral, CH2 not chiral, CH2 not chiral. Carbon of double bond, making double bond is not chiral. CH2 not chiral, CH2 not chiral. Carbon making double bond, carbon making double bond, carbon making double bond, they are not chiral. Carbon making double bond, CH2 CH2 not chiral, CH2 not chiral. Now come toward the rest of the corners. CH3 is not chiral, CH3, this carbon is not chiral, and here are 1, 2, 3, 4, 5, and 6. 6 positions are left behind. So let me check these six positions once again. OH, one side OH, one side C double bond O. This carbon is having one side CH2 and one side C. Yes, it's a chiral center. Come toward this middle one, and CH3 group, here is COH group, here is CH group, and here is CH2. Again, all 4 arms, all 4 roots are basically different, so it's a chiral. Come toward this one, it's having hydrogen on one side, CH2, CH, and here is CH3. Yes, all adjacent atoms or group of atoms are different, so it's a chiral. Come toward this one, it is once again having hydrogen. Here is CH2 on one side, here is CH, here is CH. So in this case, these both CH are same. Appear to be the same, seems to be same. But if the situation is like that, you will move one step forward. So if I'm moving in this way, here is CH2, and if I'm moving one step on the other hand with this carbon towards this side or to upward, the steps are different. It means that the 4 paths starting from this center are also different. All 4 arms are going lead to the different directions, different substituent, different group, and so on. Same is the case with this one, hydrogen, C double bond O, carbon, and CH. It's a chiral. The last one, this one, it's having just carbon over here, CH2 over here, CH3 over here, and CH over here, so it is also a chiral. So total there are 1, 2, 3, 4, 5, and 6 carbon atoms are chiral. This portion is taken from AS organic section. You may ask from organic chemistry from AS section as well. So what is its root and what are the basic region and condition? Number 1, once again, Cl is going to change itself into Cl. So you will add PCl3, PCl5, SOCl2, etc. There are 2 or 3 more options as well. Now, Cl is going to change into CN group over here. What should be done? We will have to put KCN, alcohol plus heat. So this Cl will be substituted by nitrile group. What is happening in the next step? You will see that instead of CN, we are having this acidic group. Whenever you are going to convert this CN into acidic group, it means that you are going to make acidic hydrolysis. H positive ion acid is showing the acid, and you are going to heat water H2O plus heat plus H positive ion. So there is a rupture of carbon nitrogen triple bond, and you are going to make this one into acidic group. So now you are having two group. One is the keto group. This carbon is going to constitute a ketone, and this carbon is a part of carboxylic acid. What have been done in the last step? This acid is yet intact with the molecule, but we are having secondary alcohol instead of ketone. So we are going to change ketone into alcohol. What is this mechanism? What is this reaction? This is called a reduction. But, we cannot use lithium aluminium hydride because it will reduce both carboxylic acid and this keto group as well. So you can use nickel hydrogen plus heat, or you can use sodium borohydride. You can use nickel plus hydrogen plus 300 Celsius temperature to change this keto group only into this alcoholic group, that is secondary alcohol. There are some unexpected questions as well. For example, here is a question of this unique different compound that is having nitrogen atoms and carbon-carbon double bond. It seems to be like very much similar like that of benzene ring. Now he is asking to find the hybridization of nitrogen and carbon. This is the carbon and this is the nitrogen. So what is the basic theme? What is the basic way out to diagnose hybridization? It's very much simple. First of all, mark hydrogens for your own convenience where it is feasible, at the terminal of carbons. And second thing, there's no hydrogen on the nitrogen. Second thing, mark lone pair on nitrogen, on oxygen, or any other electronegative atom where it is feasible. So, what is the basic theme? First of all, I'm going to start from the carbon. How many pairs surrounding this carbon atom? 1, 2, and this double bond is also counted 1. 1. Double bond is counted as a 1 pair. Triple bond is counted as a 1 pair. Single bond is already 1 pair. So 3 pairs are counting this carbon. So what is the sum of, which one hybridization is going to give sum 3? That is 1s and 2p is equal to 3. So sp2. This carbon is sp2 hybrid. Come towards this nitrogen. All carbon will be the same. sp2, sp2, sp2. Now come towards these both nitrogen. These both are showing the same structure. So their hybridization will also be the same. What is its hybridization? Once again, count the basically pairs, total pair of electron. 1, 1. Include the lone pair as well. Yes, include the lone pair as well. 1 bond pair, lone pair, and there are double bond, but again I'm taking 1. It's counting as a 1. So overall 3 once again over here. If the answer of the total pair of electrons surrounding any central atom is equal to 3, its hybridization is equal to sp2. 1s, 2p, sp2, and so on. Now is asking how they are making pi bonds are between carbon-carbon and between carbon-nitrogen. So you know very well that the pi bond is formed only when parallel p orbitals are available. So p orbital of the carbon atom will overlap from above and below the plane of the ring. And same is the case with the nitrogen. Same is the case with the nitrogen. If the nitrogen and carbons are lying over here, then again the p orbital of nitrogen and carbon will overlap above and below the plane of the sigma bond to make pi bond. There is only one way out. There is only one fashion to make pi bond, is the overlapping of p orbital. There is another question, unexpected and tricky question as well, that if he is starting from not from the benzene ring, but starting from this compound that is more horrible than benzene ring. Yes, it's like a benzene ring. It's an aromatic compound, but how to, deal with this such type of a compound. HNO3, you know that this molecule is used to make nitration, and he is also saying that there is a mononitration. I mean, this whole molecule, one molecule will get one nitro group on it. So you can write first molecule with one nitro at anywhere. You can place, not over here, you can place here nitro groups on these 8 positions. They are almost equal positions. But why not here? Not here, because there are no hydrogen atom. How NO2 is introduced, the basic mechanism is quite pretty similar. You can substitute nitro group by removal of H group, H atom. H atom को हटा के आप NO2 लगा सकते हैं. जहां H नहीं है, वहां आप NO2 नहीं लगा सकते. You cannot introduce nitro group with that carbon of the benzene ring that is having no hydrogen. So first of all, let's suppose I'm going to write over here nitro group. He is saying that there is the formation of isomers, products. So how to think about it? How to write the different structure? How to think that or how to make the other isomer? कैसे पता चलेगा कि मैंने जो दूसरा मॉलिक्यूल बनाया है वो इससे डिफरेंट है? तो बेसिकली आपने इन दोनों मॉलिक्यूल्स में जो पोजीशन जहां पर नाइट्रो ग्रुप नहीं लग सकता उसको रेफरेंस पॉइंट बना लें. इसको बना लें या इसको बना लें, इट्स अप टू यू. आई एम गोइंग टू टेक दिस कार्बन एज अ रेफरेंस पॉइंट. सो इस कार्बन से एट 1 कार्बन डिस्टेंस देयर इज अ नाइट्रो ग्रुप. मैं दूसरे मॉलिक्यूल में अगर नाइट्रो ग्रुप यहाँ पे लगाता हूँ NO2, दे आर नॉट आइसोमर. They are not isomer because it is also equidistant from the same carbon with the 1 carbon difference is lying over this NO2 is lying over here with the 1 carbon difference. So it's not an isomer. The both compound are having same nomenclature, same name, same structure and so on. So what to do? The next way out, search other possibility. Now the next possibility is I'm going to mark NO2 over here. I mean, from this reference point, this NO2 is present. It is basically 2 carbon away from this carbon. So it is lying over here at this position. And this, as compared to this nitro group, it is very much near to it is lying on the adjacent carbon atom. Yes, it is true. And in this nitro group, it is not at the adjacent carbon. Even you can put NO2 over here, NO2 over here, and so on. And same as the case. I mean, you can put NO2 over here, over here, over here. But keep in your mind, there is again one thing that might be wrong. If I am putting this nitro group over here, it will not be valid. I mean, you can substitute, but you should have to check it. Basically, the nomenclature of this group and this one group is quite same. Once again, I'm trying to explain this thing. Let me mark it once again over here. दोबारा देखें, गौर से देखें इस चीज को. If I'm putting NO2 group over here, these two are same. पहले लग रहा था कि हम जहां मर्जी लगा देंगे सेम हो जाएगा. नो, ऐसा नहीं है. अगर नाउ द बेसिक रेफरेंस पॉइंट इज दिस वन, द मेन जंक्शन पॉइंट. तो बेसिकली इट्स आई मीन सॉर्ट ऑफ द ट्रिकी वन. थोड़ा आपको देखना है, गौर करना है, मॉलिक्यूल को स्वैप करना है, फ्लिप करना है, चेक करना है कि किसी भी तरीके से ये पहले वाले आइसोमर की तरह सेम तो नहीं है. अगर सेम है तो फिर ये उसका आइसोमर नहीं है. So once again, I'm going to write over here, and I mean, if I'm writing the nitro group over there, NO2, yes, these two compounds are not similar. ये इस रेफरेंस पॉइंट से हो, कॉमन पॉइंट से, जो इनका कॉमन ब्रिज है, I mean, इस वाल से यहाँ पर हो, या यहाँ पर हो, या यहाँ पर हो, या. So basically, finally, I mean, you can put in next structure नाइट्रो ग्रुप ओवर हेयर, एनी ऑफ द वन पोजीशन जो मैंने मार्क की हैं, टिक लगाई हैं, आप इनमें से किसी के ऊपर तो नाइट्रो ग्रुप लगा सकते हैं, बाकी आप इन पोजीशंस के ऊपर नाइट्रो ग्रुप नहीं लगा सकते हैं। तो मॉलिक्यूल को देखना है, ये थोड़ा सा कंफ्यूजन क्रिएट कर सकता है, इतना इजी समटाइम नहीं होता, स्पेशली मॉलिक्यूल को फ्लिप करके भी आपने चेक करना है कि आर यू डूइंग वेल और रॉन्ग। The next one is one of the ones again an unexpected question, you can see. Here is the complex organic compound in step 1, step 2, and here it's going to add Y, finally making this azodie, that is congruent. So this one, once again, देखना यह है कि initial molecule कहाँ खड़ा है, इस मॉलिक्यूल में क्या क्या चेंजेस आई हैं। वैसे तो इट्स वेरी मच क्वाइट सिंपल, व्हाट यू कैन डू you can change NO2 into diazonium ion, simple. And next one, where is this Y in this molecule? Here it is, this is the Y, and if you are going to watch it clearly or keenly, I mean, again this is the Y. So 2 Y molecules or 2 mole of Y is going to react with 1 mole of Z. What is the Z? Obviously this is the Z. And you know कि जब ये एजो कंपाउंड बनता है, एजो डाई जब बनती है फाइनली, so there is N triple bond. So I'm going to move in a reverse direction once again. I'm going to mark 2 benzene ring and 2 benzene ring and at their para position N triple bond positive charge. Same is the case over N triple bond positive charge and so on. And what is the structure of Y? The similar structure, same structure. I'm going to make these 2 ring connected together. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No, it's not a pentagon, sorry. It must be hexagon. So, hexagon structure. ये दोनों hexagon structures हैं, तो yes, it's the hexagon. And don't forget to mark this circle. So here is SO3 Na positive. Let me erase this line first. It's positive, right? And here is at the para position of this group, there is NH2. I am marking NH2 over here, and that's all. That is the Y. And you know that 2 mole of Y, 2 molecule of Y or 2 mole of Y is going to mixed with 1 mole of this Z, and it's going to make this organic dye. Now what is the previous section? Obviously this NO2 group is going to change itself into NH2 group. Copy paste कर रहा हूँ मैं इसको, आपने भी ऐसा ही करना है. So here is NH2 group. Here is also NH2 group. How to bring NH2 group over here? Tin plus HCl and heat. मेरा ख्याल है आपको याद हो गया होगा, रट गया होगा आपको अब ये heat, and at the end OH negative ion is also added. In this case again NaNO2, you can also add HNO2, but I mean ज़्यादा बेहतर ये है कि आप ये लिखें NaNO2 plus HCl plus 025 or 029 degrees Celsius, and after that you are going to mix these two under alkaline condition, this organic dye is supposed to be formed. And here is another question, toughest question. Is it correct one? Let me check it. First of all, formation of cyclic compound acylation, is going to happen. Now, yes, if we are going to have AlCl3 and this one group as well, and you are going to heat, so simply speaking, it's going to snatch this Cl and it is going to generate positive ion on it. So in this case, you can see it over here. In this case, benzene ring will once again attack on this carbon atom. Benzene will attack on this carbon atom, and because this one carbon atom is going to behave as an electrophile, and you can see that 1, 2, 3, 4, and 5 and here is a 6. So basically sixth member ring is going to be formed. So a cyclic ketone is supposed to be formed. It's a unique reaction, you can say. Basically हमारे पास इस तरह का अगर कोई भी reaction आता है जिसमें formula given हो, तो एक chance ये भी है. There is one of the possible chance is over here that the same benzene ring is having two junction with other molecule. एक जंक्शन पहले यहाँ पर है इसके साथ, और इसके दूसरे पार्ट दैट वाज एसाइल ग्रुप, उसमें आपने AlCl3 ऐड किया, उसको आपने हीट किया. हीट करने के बाद अगेन द सेकंड ब्रिज, द सेकंड कॉर्नर इज गोइंग टू बी अटैच विद दिस मॉलिक्यूल. ये यहाँ पर भी अटैच हो सकता है, ये यहाँ से भी अटैच हो सकता है, ये रिंग यहाँ इस तरह का भी जो है वो बन सकता है, एंड सो ऑन. यहाँ पर भी, इवन यहाँ पर भी. लेकिन जब भी आप रिंग बनाएंगे, you should be careful about it that the ring, at least it must be 6th member ring or 5 member ring, not less than that of 5 member ring. तो एक बेंजीन रिंग अपने ही एक सब्स्टिट्यूएंट के साथ दोबारा अटैक कर सकता है और एक साइक्लिक कंपाउंड बना सकता है. एक और चांस भी है इसके अंदर, एक पॉसिबिलिटी है कि यहाँ पर एक नया बेंजीन रिंग और इस तरह का एक नया कंपाउंड भी आप अटैच कर सकते हैं. बट द बेसिक थिंग जो यहाँ पे कॉम्प्लिकेशन है वो क्या है कि इस टाइप के क्वेश्चन में हम ऐसा सोचते ही नहीं है कि ये आपस में दोबारा बेंजीन रिंग के ऊपर भी अटैक कर सकता है या नहीं. येस, बेंजीन रिंग इज बेसिकली इलेक्ट्रोफाइल सीकिंग ग्रुप, और वो जहाँ पर भी इलेक्ट्रोफाइल देखेगा उसके साथ रिएक्ट करेगा. तो 6 मेंबर रिंग अगर बन रहा है तो एक साइक्लिक स्ट्रक्चर भी बेसिकली बन सकता है. The next question is also one of the toughest question, and here there is a mechanism. ये एक अजीब सा क्वेश्चन दिया गया है, that is having this one benzene O negative ion, that is called phenoxide ion, और यहाँ पर कार्बन डाइऑक्साइड का स्ट्रक्चर है, C double bond O basically. तो he is asking to make basically an organic intermediate, and similarly next one. So let's see over here. Here is this carbon is partial positive, this oxygen is partial negative, and this oxygen is also partial negative. So obviously, if this oxygen is supposed to attack on this molecule, then it will attack on this carbon atom. And at the same time, ये क्या करेगा basically? It's one of the oxygen bond is broken. तो एक डबल बॉन्ड जो है वो टूट जाएगा, और यहाँ पर हमारे पास एक इंटरमीडिएट जो है वो बन जाएगी. Next thing, next possibility is this one, that he is saying one of the steps synthesize electrophilic substitution reaction of the carbon dioxide with phenoxide. Yes, complete the mechanism. It's electrophilic substitution. I'm wrong. My bad once again. Sorry. It's saying electrophilic substitution, and in case of electrophilic substitution, this benzene ring will attack on this carbon atom, not this oxygen. Electrophilic substitution mean nucleophile is not going to attack. Basically, electrophilic substitution mean benzene ring is going to participate, right, on the next electrophile. This is electrophile, partial positive. It's a partial negative. So yes, it's going to be broken. So what is supposed to be formed over here? Here is O negative ion. Here is one hydrogen, C O negative charge, and double bond O. Inside the ring there will be one positive charge and circle, जिसको मैंने last time आपको चांद तारा बोला था. I mean that is like that. So if this is electrophilic substitution, I thought जल्दी में कि मैंने कहा जल्दी मैं इसको कर देता हूँ, शायद ये न्यूक्लियोफिलिक हो. It's a not nucleophilic. It's not very much similar to the ketone or aldehyde. तो basically ये क्या है? It's an electrophilic substitution. Benzene ring जो है वो अटैक करेगा इसका पाई बॉन्ड इस कार्बन के ऊपर, और इन दोनों में से कोई एक बॉन्ड टूट जाएगा. Here is the ring is having positive charge, and this oxygen will get one negative charge. So generally speaking, this is the main step of the mechanism. Now the next thing is the synthesis. This is not the part of the simple major organic chemistry. I think it's a part of sort of polymerization. However, let's see how to make this cyclic compound. Once again, how to join double bonded group or compounds in a cyclic form. So here is the one mechanism that you will have to remember. I am going to shift this carbon-carbon double bond over here to make this carbon-carbon bond single bond. At the same time, there is a shifting of carbon-carbon double bond over here at this position. And this carbon-carbon double bond will be shifted over here. So what I wanted to say basically, this is the mutual shifting of carbon-carbon double bond. तीनों के तीनों double bond shift होंगे तब ये ring बनेगा. Not because of only two. If you are shifting just this one or just this one, no, it's wrong. You will have to shift all these three carbon-carbon double bond mutually on adjacent position, जैसे कि आप तमाम किस्म की polymerization में करते हैं, addition polymerization में करते हैं, and there is the formation of this cyclic ring. I think once again, same is the procedure lying over here. If the double bond is shifting over there between these two carbon atom, this double bond will be shifted over here, and this double bond will be shifted over here. So what will be the structure? One carbon, here is initially a pentagon, and 1, 2, 3, 4, 5, and 6. I mean, hexagon is supposed to be formed over here with one carbon-carbon double bond. So this is the way whenever you are supposed to make a cyclic alkene by the joining of two normal or different normal aliphatic alkenes. I think that's all about today. Thank you very much. Please subscribe my channel, hit the bell icon and share it with your friend. Thank you very much. Have a nice day.